If your software does not perform optimally, you will turn away customers who have become accustomed to speed. Now, users will simply switch off if they find your software has excessive loading time or is stalling in performance. Now, if you are losing customers, then you are losing business, most probably to your competition. Now, poor performing software will hit your business hard in the back pocket. That's exactly why performance testing plays an integral role in today's industry. Hi everyone, this is Shantini from Edureka, and in today's session, we will discuss about the top 50 interview questions for performance testing. Now, before we begin today's session, let's have a look at the agenda. So first, we will begin with a small introduction to performance testing, and then we will have a look at the different advantages of performance testing. Then we will move on to the different tools used for performance testing. And finally, we will have a look at the different interview questions for performance testing and also JMeter interview questions. So let's get started. Now, performance testing is defined as a type of software testing to ensure software applications will perform well under their expected workload. Now, features and functionality supported by a software system is not the only concern. A software application's performance, like its response time, reliability, resource usage, and scalability do matter. Now, the goal of performance testing is not just to find bugs, but to eliminate performance bottlenecks. Now, the focus of performance testing is checking a software program's speed, which basically determines whether the application responds quickly. Also, it checks the scalability. It determines the maximum user load the software application can handle. And finally, it checks the stability, which determines if the application is stable under varying loads. Now, performance testing will determine whether their software meets speed, scalability, and stability requirements under expected workloads. Applications sent to market with poor performance metrics due to non-existent or poor performance testing are likely to gain a bad reputation and fail to meet expected sales goals. Now, moving on, let's have a look at the different advantages of performance testing. The first one is validate features. Now, having a solid software foundation is a key principle of generating software success. So, measuring performance of basic software functions allows business leaders to make key decisions around the setup of the software. Then we have measure the speed, accuracy, and stability of software. Now, measuring performance, speed, accuracy, and stability is a vital aspect of software performance testing. It basically allows you to monitor the crucial components of your software under duress and can give you vital information on how the software will be able to handle scalability. Next up is keeping your users happy. Now, your first impression to prospective customers is absolutely crucial. So, measuring application performance allows you to observe how your customers are responding to your software. The advantage is that you can pinpoint critical issues before your customers. Next up, we have the improve optimization and load capability. Now, another benefit of performance testing is the ability to improve optimization and load capacity. So, measuring performance can help your organization deal with volume so your software can cope when you hit high levels of users. Finally, we have the identifying discrepancies and resolving issues. So, measuring performance provides a buffer for developers before release. So, any issues are likely to be magnified once they are released. So, performance testing allows any issues to be ironed out. It is important that performance testing is monitored across business sectors. Business leaders must have open communication channels with IT to ensure that the performance of the software can match the business strategy. Now, these were some of the advantages of performance testing. Now, let's have a look at the different performance testing tools. So, some of the best performance testing tools are the Apache JMeter, LoadView, LoadRunner, WebLoad, NeoLoad, LoadComplete, LoadNinja, and there are many more. So, now that we have seen what is performance testing and what are the advantages of performance testing, let's move on and have a look at the different interview questions for performance testing. So the first question is, what is performance testing? Now, performance testing is basically a type of software testing that ensures that the application is performing well under the workload. Now, it is mainly done for quality assurance. It involves testing software application in order to provide a better performance of your product. This also helps you in gaining the confidence of your customers. The next question is, what are the different types of performance testing? Now, performance testing has mainly 6 types. First, we have the load testing. Now, this checks the application's ability to perform under anticipated user loads. The objective is to identify performance bottlenecks before the software application goes live. Then we have the endurance testing. Now, it is done to make sure that the software can handle the expected load over a long period of time. Then we have the volume testing. Now, under volume testing, large number of data is populated in a database and the overall software system's behavior is monitored. The objective is to check software applications' performance under varying database volumes. Then we have the scalability testing. So the objective of scalability testing is to determine the software application's effectiveness in scaling up to support an increase in user load. It helps plan capacity addition to your software system. Then we have the spike testing. Now, this tests the software's reaction to sudden large spikes in the load generated by users. And finally, we have stress testing. Now, this testing involves testing an application under extreme workloads to see how it handles high traffic or data processing. The objective is to identify the breaking point of an application. Now, the next question is, what are the common performance problems faced by users? So there are certain common problems that the users face in everyday life, which is exactly why we need performance testing in order to solve these issues. So the first one is longer loading time. Certain softwares might take a longer loading time than expected. Also, there can be poor response time from the product. Then we have poor scalability and also bottlenecking, in which there might be coding errors or certain hardware issues. And to solve these problems faced by users, performance testing is used. Now, moving on, the next question is, name some of the common performance testing tools. So there are a lot of performance testing tools available in the market. And you have to select your perfect tool according to the requirement of the product. But some of the common performance testing tools are the LoadView, LoadUI, the WebLoad, Apache JMeter, NeoLoad, and there are quite a few more. So there is no best tool in the market. All you need to do is find the best tool for your performance project goals. Moving on, the next question is, list out some common performance bottlenecks. So there are 5 common performance bottlenecks, such as the CPU utilization, the memory utilization, then we have the networking utilization, S limitation, and disk usage. Next up, what are the parameters considered for performance testing? Now, before the performance testing takes place, there are certain parameters that we must consider. So let's have a look at all of those parameters that we must keep in mind. So first we have the memory usage. How much memory is being used here? Then we have the bandwidth. We must calculate the bandwidth of our product as well. Then we have memory pages, processor usage, response time, CPU interruption, committed memory, thread counts, network output queue length, and the top weights. There are certain more parameters that are to be considered, but these are some of the main parameters that must be taken care of before the performance testing takes place. Next up, what are the factors for selecting performance testing tools? Now, as I've already told you, there is no such thing as the best tool. You have to find out the tool that suits your project goals. So while selecting your performance testing tools, there are certain factors that you must consider. Some of these are the customer preference tool, the availability of license within customer machine, the availability of test environment, additional protocol support, license cost, efficiency of tool, user options for testing, and the vendor support. So you must check all of these things before you consider selecting any of the performance testing tools available in the market today. The next question is, what is the difference between performance testing and functional testing? Now, in case of performance testing, to validate the behavior of the system at various load conditions, performance testing is done. Whereas, to verify the accuracy of the software with definite inputs against expected output, functional testing is done. Also, performance testing provides the best result when it is automated. But functional testing can be done manually or automated. Now, in performance testing, several user performs the desired operations. But in functional testing, only one user performs all the operations. In performance testing, we would need a customer, a tester, developer, DBA, and a management team. Whereas in case of functional testing, we would need a customer, tester, and development involvement. Now, performance testing requires close to production test environment and several facilities to populate the load. Whereas in case of functional testing, production-sized test environment is not necessary and hardware requirements are minimal. So these were some of the differences between functional testing and performance testing. Now next question is, what is throughput in performance testing? Now for every application, there are lots of users performing lots of different requests. What you need to ensure is that your application meets the required capacity before it hits production or live. So in performance testing, throughput is referred to the amount of data transported to the server in response to the client request at a given period of time. Your throughput depends on factors like specifications of the host computer, processing overhead in the software, degree of parallelism, both hardware and software support, and types of transactions being processed. Now next question is, what are the benefits of LoadRunner in testing tools? So while using the LoadRunner tool in performance testing, it provides a versatile result. Also, the test results are quite easy to understand and it provides an accurate result as well. With the help of LoadRunner, we have easy integrations, there are robust reports, and also it provides a complete enterprise package. That's why LoadRunner is also one of the most preferable testing tools when it comes to performance testing. Now moving on, the next question is, what is endurance testing and spike testing? So first let's have a look at what is endurance testing. So it is a non-functional type of software testing. It is one type of performance testing where the testing is conducted to evaluate the behavior of the system when a significant workload is given continuously. It discovers how the system behaves under sustained use. Next, we have the spike testing. Now, spike testing is defined as a type of performance testing in which application is tested with extreme increment and decrements in the load. It is performed to estimate the weakness of an application. It is also a type of performance testing that is performed to analyze the behavior of the system when the load is increased substantially. Now, next up, what are the common mistakes done in performance testing? Now, during performance testing, we should always take care of certain common mistakes that are usually done by the users. So let's have a look at some of those common mistakes. The first one is direct jump to multi-user tests. Then we have the test results not validated. It is always important to validate your test results before moving on. Next up is the unknown workload details. You should always be aware of the workload on your software. Next is too small run durations. So your testing should not be too small. It should be at least of an average duration where you can figure out how is your product performing. Next up is lacking long duration sustainability test. Then we have the confusion on definition of concurrent users. Also, another common mistake is data not being populated sufficiently. If there is too less data, the performance testing will not give you proper results. Also, you need to figure out the difference between test and production environment. Another mistake is the network bandwidth not being simulated. Then we have the underestimating performance testing schedules and incorrect extrapolation of pilots. And finally, there's inappropriate baselining of configurations. So these are some of the common mistakes committed by the users, and you should always have a check on all of these during your performance testing. Now moving on, the next question is, what are the different phases for automated performance testing? Now the first phase is design or planning. Now what are the most important parts of the system you are testing and how do the critical components impact performance and the user experience. So a handful of API endpoints are most critical to the performance of your system. So testing your production environment requires additional planning to avoid disruption of your business. So it is very important to design or plan your performance testing beforehand. The next phase is building the structure. So according to your design or plan of your performance testing, now you need to build your software accordingly. And once that is done, the next step is the execution. Now, once you are done with the designing, planning, and building of your software, it's time you execute it and perform testing on your software. Once the testing is completed, the final phase is analyzing the report. Now, once you have done the performance testing on your software, it's time you analyze the reports and check on how your software has been performing. So, these are the different phases that are required for an automated performance testing. Now, moving on, the next question is what is the difference between benchmark testing and baseline testing? So, what is basically a benchmark testing? Now, it is the method of comparing performance of your system performance against an industry standard that is set by some other organization. So, it will compare the performance of your software with certain industry standards that are available. And it will also set a benchmark for your software that it should reach that certain level. Next is what is the baseline testing? So basically this is the procedure of running a set of tests to capture performance information. Now when the future change is made in the application, this information is used as a reference. It will always hold all the details if any changes have been made in your software. The next question is what is concurrent user load in performance testing? Now, concurrent user load in performance testing can be defined as something when many users hit any functionality or operation at the same time. It is also called as simultaneous user testing. Now, the idea behind concurrent user testing is to identify the response time of a website for a specified number of simultaneous users making requests to a website. Now, moving on, next question is what is a protocol and name some of those protocols. Now, a protocol is basically defined as a set of various rules for the purpose of information communication between the two or more systems. So, it may be a load generator, application, and web servers. Protocols include sending, receiving, authentication, and error detection and correction capabilities. Some of the common protocols include the HTTP, HTTPS, FTP, the web services, and Citrix. Next up, what is a performance tuning? Now, performance tuning is the improvement of system performance. Typically, in computer systems, the motivation for such activity is called a performance problem. Now, this can be either real or anticipated. Now, most systems will respond to increased load with some degree of decreasing performance. Now, as performance bottlenecks are identified during load testing and performance testing, these issues are commonly rectified through a process of the performance testing. Now, moving on, the next question is what are the types of performance tuning? So, we have two different kinds of performance tuning. First, we have the hardware tuning and then we have software tuning. Let's have a look at what is hardware tuning. So, enhancing, adding, or supplanting the hardware components of the system under test and changes in the framework level to augment the system's performance is called as the hardware tuning. Now, what is software tuning? Basically, identifying the software level bottlenecks by profiling the code, database, etc. Now, fine-tuning or modifying the software to fix the bottlenecks is called as the software tuning. Next up, list the need for opting for performance testing. Now, performance testing is generally required to validate the response time of application for the intended number of users. It also verifies the utmost load resisting capacity of an application. Next, it validates the capability of the app under test to handle the particular number of transactions. Also, it checks the constancy of an application under the usual and unexpected user load. And finally, it makes sure that the users have an appropriate response time on production. Now, the next question is what is the reason behind the discontinuation of manual load testing? So now these days, the automated load testing is more preferred as compared to manual load testing. This happened due to the certain drawbacks of manual load testing. Now, due to those drawbacks of manual load testing, it led to the adoption of automation load testing. Now, let's have a look at some of the reasons. First of all, the manual load testing had a complicated procedure to measure the performance of the application precisely. Then it had complex synchronization procedures between the two or more users. Also, it was difficult to assess and recognize the outcomes and bottlenecks. And finally, it increased the overall infrastructure cost. So these are some of the reasons due to which manual load testing has been discontinued and now people prefer automation load testing. Now the next question is, what is profiling in performance testing? So profiling is basically a procedure of pinpointing a bottleneck performance at miniature levels. Now this is done by presentation teams for manufacturing, which mainly includes developers or performance testers. Now profiling tools are usually only used once it has been identified that the system has a performance problem. Now if the server is taking a long time to respond and you can't identify any resource problem, profiling might be your next choice of strategy. It is best handled by a developer while the tester applies load using the performance scripts. Next up, what are the entering and exiting criteria for performance testing? Now, the starting of the performance testing is basically done at the design level only. Now, after the testing is done, the results are collected and later they are analyzed in order to make improvements regarding the performance. Now, during the whole process of life cycle development, performance tuning is done. So these are the things that are need to be considered for the entering and exiting of the performance testing. Now moving on, the next question is, what are the activities involved in performance testing? So at first we have to know all our requirements and make sure all of them are available. Next up we have the tool selection. So based on our requirements, we have to opt for a performance testing tool that will serve our purpose. The next activity is the performance test plan. So first we have to plan exactly how the performance testing will take place. And then we have to check for the performance test development. Next activity is the performance test modeling. So once the test has been developed, next step is to check the performance test model. Once the idea of how the performance testing is going to take place is ready and the model is set, the next step is the test execution. In this step, finally, the testing takes place. Next up, we have the analysis. Now, once the test is completed, the next step is to analyze how the test has been performed and what results does it show. And finally, we have the report of our performance testing. So the report provides you all the detailed information about your software and how the testing has performed. So these are the number of activities that are performed during performance testing. Now the next question is, what is stress testing and soak testing? So first let's have a look at what is stress testing. Now stress testing is a software testing activity that determines the robustness of software by testing beyond the limits of normal operation. So what is soak testing? Soak testing is basically a type of performance test that verifies a system's stability and performance characteristics over an extended period of time. So now that you know what is stress testing and soak testing, let's move on to the next question. The next question is, differentiate between performance testing and performance engineering. Now, the process of identifying the issues that disturbs the performance of any application is performance testing, whereas improving the performance of the application by observing the measurements got from the performance testing by necessary changes in terms of architecture, resources, implementation, etc. is called as performance engineering. Now, a performance tester is someone who has an understanding of how to execute load, scalability, and soak or the endurance tests. They have experience with performance testing tools like JMeter, LoadRunner, and many more. Whereas a performance engineer has skills beyond that of a performance tester. A performance engineer is capable of not only identifying a performance issue, but digging in to help identify the root cause as well. So these were some of the common questions asked for performance testing interviews. Now, JMeter is one of the most commonly used performance testing tools. So we will have a look at some of the commonly asked interview questions about Apache JMeter. So now let's have a look at the common questions asked about JMeter. So the first question is, what is JMeter? Now, JMeter is one of the Java tools which is used to perform load testing client or server applications. Now, Apache JMeter is basically an open source software. It is a 100% pure Java desktop application which is designed to load test functional behavior and measure performance of the application. Now, it was originally designed for testing web applications but has expanded to other test functions. It is also one of the most preferable testing tools when it comes to performance testing. You can also check out the JMeter tutorial in order to know more about the working of JMeter. Now the next question is, how does a JMeter work? So now a JMeter basically acts like a group of users sending requests to a target server. So what it does is it collects response from target server and other statistics which show the performance of the application or server via graphs or tables. It provides you with a generalized report with lots of graphs and tables and trees which will give you a proper analysis report of your testing. Now moving on, the next question is, what are the regular expressions in JMeter? Now the regular expressions are used to search and manipulate text. Now JMeter is useful in interpreting forms of regular expression or patterns being used throughout a JMeter test plan. This just provides a common pattern that we use during our entire process of testing in JMeter. Now the next question is, what are samplers and thread groups? So samplers and thread groups are basically two important elements of JMeter while we are performing any test using this tool. So let's have a look at what are samplers. So samplers basically allow JMeter to send specific types of requests to the server through samplers. Thread group decides which type of request it needs to make. Now let's have a look at what are thread groups. So JMeter is basically the beginning part of thread group elements. Now it is an important element of JMeter where you can set number of users and time to load all the users given in the thread group. So basically using the samplers we have our HTTP or HTTPS request that we want to send, and using the thread group we specify the number of users that are present in the thread or the number of users that are performing the testing. Now the next question is, what are the types of processor in JMeter? Now processor is basically used to modify the samplers in their scope. Now there are two types of processors in JMeter. The first one is the preprocessor and second one is the postprocessor. Now what is a preprocessor? So the preprocessor executes some action before making sampler request. So let's say you wanted JMeter to spider through the website under test, parse link and return the HTML. So you would add some actions such as the HTML link parser to your controller before creating an HTTP request. And what is a post processor? So the post processor executes some action after making a sampler request. So when JMeter sends an HTTP request to the web server under test and get the response, you want JMeter to stop the test if the server response is an error. Now you can use the post processor in order to do the task. Now moving on, the next question is, what are preprocessor elements? List some of those elements. So a preprocessor is something that will happen before the sampler executes. Now in order to configure the sample request prior to its execution, or to update variables that are not extracted from response text, preprocessor elements are used. Now some of the elements include the HTTP URL rewriting modifier, the HTTP user parameter, the HTML link parser and also the bean shell preprocessor. Moving on, the next question is, what is a timer in JMeter? Also, what are the different types of it? Now a JMeter thread by default will send requests continuously without any pause. To get a pause between the requests, timers are used. Now, if you perform load or stress testing on your server without any delay, it will be overloaded. Then it won't be able to give you realistic results and fail to simulate real-world user traffic experience. Now, JMeter timers are the solution to all these problems. The timer element can be added in a test plan to apply weight between each sampler or request. Now, let's have a look at some of the types of timer in JMeter. So first we have the constant timer. Now the constant timer element delays each request in a thread group for the same amount of time. Then we have the Gaussian random timer. Now the Gaussian random timer element is used to delay each user request for a random period of time. It has a random deviation around the constant delay offset based on Gaussian curve distribution. Then we have the synchronizing timer, which is used for synchronizing the wait period. And finally, we have the uniform random timer. Now, the uniform random timer element is used to delay each request for a random period of time. So, your total amount of delay will be equal to random delay maximum plus your constant delay offset. The next question is, what is test fragment? Now, test fragment is basically a type of element like thread group element. Now, the only difference is test fragment is not implemented unless it is referenced by either a module controller or an include controller. So basically, it is an element that can be added directly under JMeter test plan like the thread group, but it does nothing except holding other elements inside. It gets executed only when it is referenced by a module or include controller from other thread groups. So the next question is, what is assertion in JMeter and what are the different types of assertion? Now, assertion basically helps to verify that the server under test returns the expected results. Some commonly used assertion in JMeter are the response assertion, duration, size, XML assertion, and HTML assertion. So the response assertion facilitates the user by comparing the server response against a string pattern to check that the result is as expected. For example, while waiting for a response from the server, the response assertion role is to verify that the server response has probable pattern string or not. Now, in case of duration assertion, you may need to test the response from the server reaches in user-defined time. If it takes longer than the defined time, server response fails. Then we have the size assertion. Now, it is to test that each response coming from server holds the expected number of bytes. It basically facilitates the user to specify the size that is equal to, greater than, less than, or not equal to a given number of bytes. Now, for example, if the response packet from a server is less than expected 5000 bytes in size, then a test case pass, else a test case will fail. Then we have the XML assertion, which verifies that the response coming from the server holds the data in a correct XML format. And finally, we have the HTML assertion. It is helpful for checking the syntax of the response data. Now moving on, the next question is, what is the execution order of test elements? So first we have the configuration elements, and then we have preprocessors, then timers, samplers, post-processors, assertions, and finally listeners. Now timers, assertions, pre and post processors are only processed if there is a sampler to which they apply. The logic controllers and samplers are processed in the order in which they appear in the tree. Now other test elements are processed according to the scope in which they are found and the type of test element. So this was the execution order for the test elements. Now moving on, the next question is, what are configuration elements? Now a configuration element works parallel with a sampler. To set up defaults and variables for later use by samplers, configuration elements can be used. Now at the start of the scope, these elements are processed before any samplers in the same scope. So the config elements in JMeter are used to configure or modify the sampler requests made to the server. These elements are added at the same or higher level of the samplers that we want to configure. Some of the configuration elements in JMeter include the CSV dataset config, the HTTP cache manager, HTTP cookie manager, user-defined variables, random variable, and quite a few more. Now moving on, the next question is how to reduce the resource requirement in JMeter. Now to reduce the resource requirements in JMeter, we should use the non-GUI mode. So for that we have the command as JMeter-n-t and then the location of the test script, then -l and the location of your test results. You can also check out the load test using JMeter tutorial in order to understand how to perform load testing in JMeter in the non-GUI mode. Next up, during the load, test doesn't use the view results tree or view results in table listeners. It uses them only during the scripting phase. Also, we should not be using the functional mode. And finally, instead of using lots of similar samplers, we must use the same sampler in loop and use variable to vary the sample. So if we follow these steps, it will help us in reducing the resource requirement in JMeter. Now moving on, how to perform spike testing in JMeter. Now by synchronizing timer JMeter, spike testing can be achieved. So synchronizing timer blocks the thread until a specific amount of threads has been blocked and then release them all together, thus creating large instantaneous load. Now moving on, the next question is mention some of the JMeter listeners. Now listeners are the JMeter component that displays the test results, but there is more to them than just that. The variety of JMeter listeners enables performance engineers to monitor the requests sent from JMeter as well as to analyze the responses received from the system under test. So some of the JMeter listeners include the spline visualizer, the aggregate report, the view result tree, view result in table, monitor results, distribution graph, bean shell listener, and the summary report. Now for each sample, the HTTP sampler produces the view results tree listener provides the request parameters, response parameters, and the response data. And also, one of the most useful elements of the view results tree listener is a tab that renders information transmitted in the sample body into the required format. Also, the view resultant table listener displays information about each sample in the form of a table. So the table shows time-related data for each sample, the payload data, the thread number, and the sample execution result. Next question is how to capture the script of the authentication window in JMeter. So normally you can capture the script by recording. So for that, first you have to thread group in test plan and then make HTTP proxy server in Workbench. And after that, you have to set the port number in global setting box and modify your connection setting in IE as localhost, in address 8911 as input. Then you can start your HTTP proxy server in JMeter and run your application for login. While you follow these steps, it will help you capture the script of your authentication window in JMeter itself. Moving on, the next question is what are the types of controllers in JMeters? Now normally we construct test plan which consists of small units of functionality like login, add product or logout. Now the functionality can be stored inside controllers as modules. Now there are two main types of controllers in JMeter. That is the samplers controllers and the logical controllers. Now samplers allow JMeter to send specific types of requests to a server. They basically simulate a user's request for a page from the target server. For example, you can add an HTTP request sampler if you need to perform a post, get, delete on a HTTP service. Next up is the logical controllers. So the logic controllers let you control order of processing of samplers in a thread. So the logic controllers can change the order of requests coming from any of their child elements. Some examples are the for each controller, while controller, loop controller, if controller, the runtime interleave controller, throughput, and run once controller. So these were two main types of controllers in JMeter. Now moving on, the next question is what are preprocessor and post-processor elements? So what are preprocessor elements? So a preprocessor is something that will happen before a sampler executes. So they are often used to modify the settings of a sample request just before it runs. And next up we have the post-processor elements. So a post-processor executes after a sampler finishes its execution. This element is most often used to process the response data. Now moving on, the next question is what are the different uses of monitor test? Now monitors are useful for a stress testing and system management. It is also used with stress testing. The monitor provides additional information about the server performance. Monitors also make it easier to see the relationship between server performance and response time on the client side. And finally, as an administration tool, the monitor provides an easy way to monitor multiple servers from one console. Now, next question is what are the benefits provided by JMeter for performance testing? Now, JMeter is one of the most preferred tools when it comes for performance testing. So let's have a look what are the benefits that it provides which makes it one of the most preferred tools. So some of the benefits on performance testing that JMeter offers are that it can be used to test performance for both static resources as well as dynamic resources. Not just that, it can also handle a maximum number of concurrent users than your website can handle. And finally, it provides the graphical analysis of performance reports. The next question is what is distributed load testing and how to achieve it? Now, basically, distributed load testing is a process through which numerous systems can be used for simulating a load of a large number of users. Now, by using the master-slave configuration, JMeter can do the distributed load testing. Now, as a single system cannot generate large number of threads, multiple systems are used for this testing. So in this case, the system running JMeter GUI control each slave, and the web server under test gets a request from these slaves, whereas the system running JMeter server receives a command from the master. And this is how the master-slave configuration works and helps the JMeter in performing the distributed load testing. Now, what are the different ways of data parameterization in JMeter? Now, instead of putting the hard-coded value as input parameters for a functional or API testing, you might have thought about how we can use a file, table, database objects for better test coverage. Parameterization is the answer to it. So data parameterization makes the scripts reusable where the values need not be hard-coded for the same request with different parameters. Now the different ways are the CSV dataset configuration and the user-defined variables. Now we can easily parameterize that request by using an external CSV file and running the script across different users. And another method is by using the user-defined variables in case of data parameterization. Now moving on, the next question is what are the differences between JMeter and LoadRunner? So JMeter is basically an open source tool, whereas LoadRunner is a licensed software. JMeter was also developed by Apache and LoadRunner was developed by Mercury. One problem in JMeter is that it lacks in the user interface, but in case of LoadRunner, it has a very impressive user interface. JMeter is also considered to be less technically sound when compared to LoadRunner because LoadRunner has more technical capabilities. Also, JMeter doesn't support the SAP and Siebel, whereas LoadRunner supports SAP, Siebel, and also PeopleSoft. But because JMeter is an open source tool and readily available, it is still considered to be one of the most preferred tools when it comes to performance testing. So these were some of the differences between JMeter and LoadRunner. Now moving on, the next question is what are the important plugins supported in JMeter? Now JMeter supports different types of plugins which are helpful in generating high quality results. Some of the major plugins that are supported by JMeter include the Thread Group plugin, the Stepping Thread Group plugin, and next up is the Samplers plugins like the Web Driver. And finally, we also have the Listeners plugin. So these are some of the most important plugins that are required and also supported in JMeter. Now moving on, the next question is mentioned the differences between JMeter and SOAP UI. So JMeter is basically used for load and performance testing, HTTP, JDBC, JMS, web service and etc. Whereas the SOAP UI is specific for web services and has a more user-friendly IDE. JMeter also supports the distributed load testing, but SOAP UI does not support the distributed load testing. The JMeter kit and the load generator plugins are needed for IDE, whereas in case of SOAP UI, for most IDE it has the plugin support. So now let's move on to the final question of this section. So the final question is, what is Workbench? Now Workbench is basically a storage area for adding some components which can be added to test plan if required. Components of Workbench does not get saved with the test plan automatically. They have to be saved separately as test fragments. So these were some of the most commonly asked questions on performance testing and JMeter. These interview questions will help you in clearing your interviews about testing. You can also go check out our software testing interview questions if you are preparing for any interview for a role in testing. I hope this video will help you get through your interview. So don't forget to let us know about your opinion in the comment section below. Till then, thank you and happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!